Okay, today we're going to look at square roots of complex numbers, square roots, cube roots, and fourth roots. And we're going to look at complex numbers, and we're going to mostly look in polar form. Okay, complex numbers. All right, let's do it. Let's take the square root of 1 plus root 3i. I use this complex number a lot. 1 plus root 3i. It's a good one. We've worked that out before. We know this is the same as, if I could convert this into polar form, it's got a magnitude of 2, right? 1 squared plus root 3 squared is, that square root is 2. And cis, or square root, of pi on 3. Okay, so we do inverse tan of root 3 on 1. Inverse tan of root 3 is pi on 3. Okay, and of course we're in the first quadrant. We'll just check that the angle makes sense. So 1 to the right and root 3 up. Yep. Okay, so we're really trying to find the square root of this number. Okay, we can use De Moivre's theorem to do that because this is the same square root. It's the same as 2 this pi on 3 all to the power of 1/2, isn't it? So the square root is the same as the power of 1/2. Okay, so we can use De Moivre's theorem if we like. So we go 2 to the power of 1/2 this of 1/2 of times pi on 3, which is pi on 6. So here I've got root 2 cis pi on 6. Okay, but this is not the only square root we can have. When we're in polar form, because we've got, if we think about our complex plane, now we are expecting, when we take a square root, that we'd have 2 solutions here. Yeah. So one solution, it should be evenly spaced, basically. So this is one solution, which is root 2 pi on 6, which is that distance there, and yeah. So it's over here. This is our imaginary. Oh, sorry, this is our reals. How did I get that wrong? Imaginary. That's RE there. Real part of Z. Okay, so this has a magnitude of root 2 and angle pi on 6. Now the other solution, now all the solutions have to be evenly spaced. So we're expecting for a square root, we'd have 2 solutions. So the other solution would be over here. Yeah, evenly spaced. So a distance of pi apart. A rotation of pi apart and the same magnitude. So the other solution is going to be right, this root 2 cis pi on 6 plus pi. Let's do minus pi so we get our argument in the right spot, which is root 2 cis of negative 5 pi on 6. Okay, so both of these solutions to this. Now we could re-expand this if we wanted to. I'm not going to, but you could. Root 2 cos of negative pi on 6 plus I root 2 I sine of negative 5 pi on 6, and we get the answer. Okay, so if we had to convert it back to Cartesian, we would do that. In the interest of saving time, let's do a cube root. So what is the cube root of 8? Okay, so we're thinking this is we want all the complex solutions as well. So this is the complex number, just 0 plus 0i. Okay, cube root of 8. Let's change it to polar form. Okay, so 8 is on our real axis, yeah, no imaginary part. So it's just 8 cis of 0 degrees, yeah. And we want the cube root. Okay, so we want the cube root, so that's the same as to a power of 1/3. Power of 1/3 is a cube root. Okay, so 8 to the power of 1/3 cis of 1/3 of 0. That's one solution. Okay, so that's just 2 cube root of 8. 2 cis of 0, yeah? But we want 3 solutions for the cube root, yeah? So we want them spaced evenly throughout the circle. So we're going to add 2 pi and 3 and minus 2 pi and 3. So 2 pi is all the way around. We're expecting 3 solutions. We're going to divide it up into 3 equal bits, so 2 pi and 3. So we could have 2 cis of 0 plus 2 pi and 3, which is just 2 pi and 3. Or, finally, we go 0 minus 2 pi and 3. So 2 cis of 0 minus 2 pi and 3. There's our 3 solutions. Could expand this back out. Of course, we get the answer 2, which is what we expect when we say cube root of 8. That's maybe this one. Or, what's this one going to be? 2 cos of 2 pi and 3. 2 pi and 3, that's 1/2, but it's negative, so we've got -1 plus root 3i. Or 2 times cos of -2 pi and 3, -2 pi and 3. That's -1/2, so we've got -1 minus root 3i. Okay, there we go. So that's just expanding out those complex numbers into regular form, or rectangular form, I should say. Get rid of this. The last one, still fourth root. Fourth root's great. Let's do this in a different way. Instead, 4 plus 64 equals 0. All right. So this is the same as finding the fourth root, 64. This. What do we get now? We're going to change this into polar form. And -64. That's z to the 4, magnitude of 64, this of pi. Yes, because it's on the real axis. No imaginary parts, no up and down bits. So sine of pi is 0. That makes sense. Think about it like that. Okay. So we want z is equal to the 4th root, or the 4th power of this, 1/4. 64 to the power of 1/4, this of pi on 4. I'm multiplying the angle by 1/4. This is 4. 4 to the power of 4, 64. This of pi on 4, but they've got to be evenly spaced, so 2 pi on 4, that's the same as pi on 2. So I can add pi on 2 to this answer. Gives me 4 this of 3 pi on 4. Yeah. Or, what else? 4 cis of, if I minus pi on 2 away. Did I say pi on 2 before? I meant pi on 2. So pi on 4 plus pi on 2 gives us this. Pi on 4 minus pi on 2 gives me negative pi on 4. Or 4 cis of pi on 4 minus pi on 2 minus another pi on 2 gives me 3 pi on 4. And that gives me 4 evenly spaced solutions, all 90 degrees from each other. And you can expand those out if you wish to put in rectangular form. I'm just going to leave them in polar form. That's it for this lesson.